Talking about the fundamental forces of the universe and what it's actually made of.
So, okay, let's unpack this a little bit.
Okay.
The Higgs boson is this tiny particle that gives other particles their mass, right?
Right.
But dark matter is this invisible stuff
Yeah.
that we can only detect through its gravity.
Yeah.
So how could those two possibly be connected?
Well, imagine the Higgs field like a giant, cosmic swimming pool
Yeah, okay.
filled with honey.
Yep.
Some particles, like those that make up and the things we see, are wading through that honey, interacting strongly with the Higgs field and gaining mass. Others, like photons, barely feel it at all and stay light.
So where does dark matter fit into this cosmic pool party?
That is the million-dollar question.
Yeah.
One leading theory, called the Higgs-portal model, suggests that dark matter particles might actually interact with the Higgs field too.
Okay.
It's like they're having a secret handshake with the Higgs boson, exchanging information and potentially even gaining mass through this interaction.
This is where things get mind-blowing.
Right.
So you're telling me that the Higgs boson could be the reason dark matter has mass?
It is a big leap.
That's huge.
But it could also help solve another big mystery. How heavy are these dark matter particles actually?
Oh, okay.
You see, if they're too heavy, their interaction with the Higgs field could affect the Higgs boson's own mass, which we know very precisely.
So it's like a cosmic balancing act.
Exactly.
Too much weight on one side and the whole thing tips over.
Yeah, researchers have even estimated an upper mass limit for dark matter particles.
Oh.
Somewhere around a few thousand GeV.
Okay, GeV sounds pretty technical.
Sure.
What does that actually mean for us non-physicists out there?
Think of it like this. 1 GeV is roughly equivalent to the mass of a proton.
Okay.
So we're looking for dark matter particles that are thousands of times heavier than a proton,
Okay.
but not so heavy that they throw the whole system out of whack.
Okay, so we've got this Goldilocks zone for dark matter mass thanks to the Higgs boson.
Right.
But how are scientists actually looking for these elusive particles?
You could say that there are
Yeah.
two main approaches.
Okay.
Smashing particles together at incredibly high speeds and building ultra-sensitive detectors deep underground to catch those rare moments when a dark matter particle might bump into something.
Okay, smashing things together sounds intense.
It is.
Can you tell me more about that?
Well, the Large Hadron Collider, or LHC, is the world's most powerful particle accelerator.
Wow.
It's a massive underground ring where protons are smashed together at nearly the speed of light.
Oh, wow.
The idea is that if the Higgs boson and dark matter are linked, you might see the Higgs boson decaying into invisible particles, which could be those elusive dark matter particles.
So they're looking for missing energy like a ghost in the machine.
Exactly.
That's pretty ingenious.
One experiment at the LHC, called 8TLA, is specifically looking for these telltale signs of the Higgs boson decaying into something we can't see.
And what about those underground detectors?
Yeah.
What's happening there?
These experiments are like setting a trap and hoping the cosmic critter wanders in.
Okay.
They're buried deep underground to shield them from all sorts of background noise and interference.
Uh-huh.
And they're packed with super-sensitive detectors.
Okay.
One famous example is the Xeon N1T experiment, which uses a huge tank of liquid xenon.
Okay.
If a dark matter particle happens to collide with a xenon atom, it creates a tiny flash of light that the detectors can pick up.
So it's like waiting for a dark matter whisper in the silence of the underground?
Yeah.
Have we actually detected anything yet?
Not directly, no.
Okay.
But these experiments are incredibly valuable
Yeah.
because they help us rule out certain possibilities
Yeah.
and narrow down the search. Each experiment, even those that come up empty, tells us something valuable about what dark matter might and might not be.
Oh, wow.
It's a process of elimination, and we're slowly closing in on it.
So the Higgs-portal model seems like the leading contender in this cosmic mystery.
It's a good one.
But are there any other theories out there trying to explain the connection between the Higgs boson and dark matter?
Oh, absolutely. The world of theoretical physics is full of creative explanations.
Hold on to your hats, because this is where things get really wild.
Indeed. Two other frameworks worth exploring are supersymmetry and the mind-bending concept of extra dimensions.
Supersymmetry, extra dimensions, those sound like they're straight out of a science fiction movie.
You do, don't they?
Yeah.
But they're based on some very real physics.
Okay.
Supersymmetry, or CDSY for short, suggests that every known particle has a superpartner,
Okay.
a heavier undiscovered particle.
Mm-hmm.
And some physicists think the lightest of these superpartners, called a neutralino, could actually be dark matter.
So we just need to find these super partners to unlock the mystery.
It would help.
That sounds like a whole other treasure hunt.
It is a challenge.
Yeah.
And then there's the idea of extra dimensions.
Okay.
This one really stretches the imagination,
Yeah.
but it suggests that there could be hidden dimensions beyond the three spatial dimensions we experience.
Okay, that's a mind-bending concept.
It is.
How do physicists even begin to test for extra dimensions?
It's all about looking for indirect evidence,
Okay.
like deviations from the expected behavior of particles or forces.
Okay.
Imagine a guitar string.
Okay.
You can only see its one dimension, but you hear its vibrations, which tell you something about the string's properties.
Okay.
Similarly, we might be able to see the effects of extra dimensions on the particles and forces we can observe.
So dark matter might exist as excitations within these hidden dimensions,
It's possible.
kind of like ripples on a cosmic pond?
Yeah, it's a fascinating possibility,
Yeah.
and one that physicists are actively investigating.
All right, so we've got Higgs portals, super partners, and hidden dimensions.
A lot to think about.
Sounds like physicists have their work cut out for them.
We do.
But are these just cool ideas, or are they actually testable?
That's the beauty of scientific theories. They lead to testable predictions.
Oh, okay.
We're not just throwing darts in the dark here.
Right.
Experiments at the LHC and other facilities are actively looking for evidence to support or refute these theories.
So as we wrap up part 1 of our deep dives, where do things stand?
Yeah.
Are we any closer to cracking the Higgs dark matter code?
Well, we're still in the midst of the puzzle, that's for sure. There are a lot of challenges.
Right.
But the good news is there's a lot of exciting research happening on all fronts.
It's a race against the cosmic clock then.
It is.
We'll be back with part 2 of our Higgs and dark matter deep dive soon.
Sounds good. It certainly is a race, but it's more of a marathon than a sprint.
Right.
We need to be thorough and meticulous.
Right.
And thankfully, there's a fantastic sense of global collaboration in this search.
It's amazing to think of scientists all over the world working together to solve one of the universe's biggest mysteries.
Yeah.
What are some of the most promising avenues of research right now?
Well,
What has you particularly excited?
for one, we have new, even more powerful particle colliders being planned.
Oh, wow.
Imagine these machines will be able to smash particles together at even higher energies,
Okay.
potentially giving us a clearer picture of what's happening at the subatomic level.
We're talking about going deeper down the rabbit hole then.
Yeah, exactly.
What kind of impact could these new colliders have on the search for dark matter?
They could be game changers with higher energies. We might be able to directly produce dark matter particles
Oh, wow.
instead of just inferring their existence from missing energy.
Right.
It's like going from trying to hear a whisper to having someone shout the answer right in your ear.
That would be a breakthrough moment for sure.
It would.
But it's not all about brute force, right?
Right.
What about the data we already have and the
Yeah.
exciting developments on that front?
Absolutely. We're developing increasingly sophisticated algorithms and machine learning techniques to sift through the massive amounts of data generated by experiments like the LHC.
Okay.
This could help us spot subtle patterns and anomalies that might have been missed before.
So it's like having a superpowered detective
Yeah,
combing through the evidence, finding clues that were always there, but we just couldn't see them before.
exactly. And then there's this incredible new approach called multi-messenger astronomy.
Okay.
It involves combining data from different sources,
Okay.
not just particle colliders, but also telescopes that detect light neutrinos and even gravitational waves.
Wait, hold on. Gravitational waves, those ripples in space-time caused by black holes colliding?
Yes,
How do those fit into the dark matter puzzle?
it's still early days, but if dark matter interacts with itself in certain ways, it could produce gravitational waves that we might be able to detect.
Okay.
Imagine the possibilities if we could listen in on dark matter's conversations using gravitational waves.
Wow. That's incredible. So we've got powerful new colliders on the horizon,
Yes.
clever algorithms sifting through data,
Uh-huh.
and a multi-messenger approach bringing in all sorts of cosmic signals.
It's exciting.
It sounds like we're on the cusp of some major discoveries.
I'm optimistic, but it's important to remember that scientific progress is rarely a straight line.
Right.
There will be setbacks, false leads, and unexpected challenges along the way.
Of course.
But that's what makes it so exciting. Each challenge brings us closer to understanding this fundamental piece of our universe.
The thrill of the unknown, right?
Absolutely.
There's nothing quite like a good mystery, especially when it comes to the universe.
Yeah.
So far, we've mainly talked about how the Higgs boson might help us unlock the secrets of dark matter. But what about the other way around?
Yeah.
Could studying dark matter help us learn more about the Higgs boson?
That's a brilliant question. And the answer is a potential yes. Remember the standard model of particle physics, which describes all the known particles and sources, has been incredibly successful?
Yes.
But it has some gaps, and one of them is that it doesn't explain why the Higgs boson has the specific mass it does.
So the Higgs boson itself is a bit of a mystery.
In a way, yeah,
We know it's there, we know what it does,
right?
but we don't fully understand why it is the way it is.
Exactly. And some physicists believe that dark matter might hold the key to solving this puzzle.
Okay.
For example, if dark matter interacts with the Higgs field, it could contribute to the Higgs boson's mass.
So dark matter could be like the missing ingredient in the recipe for the Higgs boson's mass.
You could.
Like that pinch of salt that brings out all the flavors.
That's a great way to put it. By studying how dark matter interacts with the Higgs boson, we might refine our understanding of the Higgs mechanism and the very nature of mass itself.
I'm starting to see how intertwined these two mysteries really are.
Yeah.
It's like they're two sides of the same cosmic coin. But with all this talk of potential breakthroughs and new discoveries, I have to ask,
Oh, okay.
what are the stakes here?
Yeah.
Why should we as non-physicists care about the connection between the Higgs boson and dark matter?
That's a question every scientist should be prepared to answer.
Right.
On a fundamental level, it's about understanding our place in the universe.
Okay.
Humans have this innate desire to make sense of the world around us.
Right.
And uncovering the secrets of dark matter and the Higgs boson is like piecing together a grand cosmic puzzle.
Right.
And who doesn't love a good puzzle?
I love that analogy.
Yeah.
But are there any practical implications? Could these discoveries lead to new technologies or innovations?
History has shown us that fundamental scientific discoveries often lead to unexpected technological advancements down the line.
Okay.
While we can't predict exactly what those might be, a deeper understanding of the universe at its most fundamental level could have profound implications for our future.
Right.
It's like opening the door to a whole new world of possibilities.
All right, so we've covered a lot of ground in this deep dive so far.
Yeah.
We've talked about the Higgs boson, the mystery of dark matter, the potential connection between them, the cutting-edge experiments searching for answers, and the mind-blowing implications of what we might discover.
It's been a lot.
But as we wrap up part 2, I have one final question for you.
Okay.
What's the most intriguing, unsolved question that keeps you up at night when it comes to this whole Higgs dark matter puzzle?
That's a tough one. There's just so many fascinating questions, but I guess for me the biggest one is, if dark matter interacts with the Higgs field, does that mean it also experiences the other fundamental forces like the weak force and the strong force?
Whoa, you're going deep now. Why is that question so significant?
Because it gets to the very heart of what dark matter is.
Okay.
If it only interacts through gravity, as we currently believe, it's like a cosmic ghost passing through everything else.
Yeah.
But if it feels the other forces, even very weakly, it means it's more connected to the fabric of our universe than we ever imagined.
And that could completely change our understanding of how the universe works.
Absolutely, it would be a paradigm shift.
Yeah.
And who knows what other secrets of the universe might be revealed along the way.
Okay, so we've established that the connection between the Higgs boson and dark matter is this mind-blowing cosmic mystery with potentially huge implications. But let's say, for argument's sake, that we crack the code. What then?
Yeah.
What could we actually with this knowledge?
That's where things get really exciting.
Yeah.
And a little bit speculative.
Right.
But let's indulge our imaginations for a moment. Imagine we could not only detect dark matter, but actually study it in detail.
Like capturing a dark matter particle in a lab and getting a closer look at this cosmic ghost?
Sort of, we wouldn't be poking and prodding it in the traditional sense, since it doesn't interact with light or matter in what we're used to.
Right.
But we could analyze its properties, figure out how it interacts with other particles, and maybe even harness its unique characteristics.
Okay, I'm already picturing all sorts of sci-fi scenarios.
Right.
New forms of energy faster than light travel.
Yeah.
Warp drives? Is that where we're headed?
Hold on there. Let's not get ahead of ourselves.
Okay.
Those ideas are fun to think about, but they're still firmly in the realm of science fiction.
Okay.
But that doesn't mean there wouldn't be practical applications.
So what kind of real-world impact could we expect?
Well, for one, a deeper understanding of dark matter could revolutionize our understanding of astrophysics and cosmology.
Okay.
We could create more accurate models of galaxy formation map, the distribution of dark matter throughout the universe, and maybe even solve some of the biggest mysteries of the cosmos.
So from the tiniest particles to the largest structures in the universe, dark matter is the key.
It's certainly a major player. And then there are the potential technological applications. Who knows what new materials, computing technologies, or even communication systems we might develop based on our knowledge of dark matter.
It's like a whole new frontier of science and engineering just waiting to be explored. It's mind-boggling.
It truly is, and it all hinges on understanding this fundamental connection between the Higgs boson and dark matter. It's a puzzle that could unlock some of the most profound secrets of the universe.
Well, after this deep dive, I can confidently say that I'm even more fascinated by the Higgs boson dark matter and the cosmic dance they seem to be engaged in. What a journey.
It's been a pleasure exploring these ideas with you. It's truly awe-inspiring to be a part of this scientific endeavor.
And for you listening out there, if this deep dive has sparked your curiosity, don't stop here. There's a whole universe of information out there waiting to be explored. Keep asking questions, keep learning, and who knows, maybe you'll be the one to make the next big breakthrough. Until next time, keep looking up and stay curious.